Bioequivalence study design selection basics is the topic of this video, and I hope you will find this video as very informative and very important to understand how the bioequivalence study design is selected for the new formulations as well as for the generic formulations. So welcome all the viewers and professionals to the video, and let's start with some basics. Whenever you are dealing with the BE study design, you should understand and should know the key parameters related to the drug molecule which are important for the study design selection. First is biovariability or variability in the absorption, metabolism, or variability in the pharmacokinetics. Variability for the drug molecules may be low or high. Another one is half-life. Half-life may be long or half-life may be short. Another is therapeutic index. Drug may have normal or non-NTI therapeutic index, or it may have narrow therapeutic index. And we should also know regarding the B designs. So main B designs are parallel design, crossover design, and replicate designs. In replicate design, there are two types: full replicate and the partial replicate design. First is drug variability. So this is variability related to the ADME. If drug is highly variable, that time the drug shows high intra-subject variability, and if the drug is highly variable, that time replicate crossover study is performed. This variability is intra-subject variability, and the general criteria is 30%, and the reference formulation should also show more than 30% intra-subject variability. Then you can go for the crossover study replication, that may be full replicate or partial replicate. Partial replicate study involves dosing the reference 2 times and test product 1 time, and full replicate will involve reference product 2 times and test product 2 times. So that is 4-way crossover or 3-way crossover. This replicate crossover study is done as it reduces the bias in the formulation. You will know whether the inequivalence is because of the formulation or because of the inherent properties. And this design, that is replicate crossover design, can provide the reference scaling by a statistical method used to assess the bioequivalence of test drug compared to the reference drug. So whenever you find that the drug is highly variable, then you should think about the parallel, then you should think about the crossover study and not the parallel study. So replicated crossover design accounts for the for the intra-subject variability, and it also provides you the scaling of B limits by reference scaling. It also decreases or reduces the formulation bias. And if you find that the drug is not variable or it is low variable, then check its half-life. So first is variability. If the drug is highly variable, that time go for the replicate crossover design. If it is low variable, then check its half-life. So half-life may be long half-life or short half-life. This time variability will be low, but half-life may be long or short. If the half-life is long, that means if half-life is more than 24 hours, then go for parallel design. So in parallel design, two groups are made. One group is given test product and another group is given the reference product. Parallel design reduces the time required for the bioequivalence study as it can avoid the long washout periods. So washout period is calculated from the half-life, and generally 5 to 6 half-life washout period is given. Minimum washout period is avoided also in the bioequivalence studies. Generally, as a general practice, washout period more than 5 half-life is provided. Then if the drug is having short half-life, that means less than 24 hours, then a standard crossover design is selected. Standard crossover design detects the differences between reference and test parameters in the same subjects. So in this, the same group receives the test and the same group receives the reference formulation. Now if the drug is low variable and if it is having short half-life, but if its therapeutic index is narrow, then we should go for the another design. This drug may be with less variation or less variability and short half-life, but the drug may be with narrow therapeutic index, or it may have a good therapeutic index or wide therapeutic index, or we can say that non-narrow therapeutic index. If the drug is with narrow therapeutic index, then select the crossover design and apply the strict B criteria, that is 90 to 111% for T by R. And if the drug is under the category of narrow therapeutic index, then the close monitoring of subjects which are undergoing the study is to be done to record adverse effects and to monitor the safety. If the drug is not variable, it is having short half-life and it is non-NTI, then directly we can select the standard crossover design. Now we will see the examples. Metformin hydrochloride is the drug with short half-life of around 6 hours. It is not a narrow therapeutic index drug. So directly single dose 2 treatment 2 period crossover design can be taken for in vivo BE study. Now for long half-life drug, example is hydrochloroquine sulfate, hydroxychloroquine sulfate. Half-life is around 22 days. So for this parallel design will be selected. So for hydroxychloroquine sulfate, single dose 2 treatment randomized parallel in vivo B study design is selected. Now coming to the example of NTI drug, warfarin sodium. 4-way fully replicated crossover design in vivo B study. And why this study is selected? Because it is NTI drug and the fully replicate crossover design will be important and it will be selected in order to scale bioequivalence limits to the variability of the reference product. Also to compare test and reference product for within subject variability. So this was regarding the selection of bioequivalence or B study design based on to the drug properties. I hope this video will help you to understand how the B designs are selected. Thank you for watching the video and let's meet soon with such kind of informative video. Thank you.